Hi, my name is Clifton Landry, and my presentation today is going to be about the genetic algorithm. The genetic algorithm was created originally for optimization, but over time, other algorithms have outperformed it. However, in modern day, it is now used specifically for predictive analysis software, and predictive analysis can be ranging from a lot of topics. Usually, it involves medical research. It also can involve financial markets, and even more unique uses, like figuring out which parts of a field need herbicide and which parts do not. So let me get into it. To begin, I want to start with some base knowledge. It's called the genetic algorithm because it's based off of meiosis, which is the reproduction of sex cells. For some basic terminology, the chromosomes represents the data being altered. In this example, I'm going to be using strings, binary strings, to represent the chromosomes. However, they can be more complex strings of data. The genes represent the individual elements that make up the chromosomes. The population is all of the chromosomes together. The generation is the chromosomes present in the current iteration of the algorithm. And overall, the algorithm is a six-step process that'll be repeated multiple times to optimize and predict what the data is trying to be worked for. So to start in part one, we have the initial population. The chromosomes are created, and they're often giving randomly generated values. They can use default sets of data. However, if you're truly following the way of the genetic algorithm, there should be more randomly generated values to create more diversity. And here on the right, we have our four data values that I'm going to be using for the examples coming up. The second step of the genetic algorithm is the fitness function. During the fitness function, we are going to take each chromosome and assign a fitness value to it. The lower the fitness value, the closer the chromosome is to the solution. So we can see over here on the right that a chromosome like 111111 has a value of 1, which means it is very close to the solution. Meanwhile, something like this one up here has value 10, which means it is pretty far from the solution. These chromosomes compete against each other, and this competition only looks at the current generation. This is the hardest step to create, mostly because you have to figure out how close you are to the solution from looking at the chromosomes. This is a very integral process to the overall genetic algorithm because these fitness values will get used again in later calculations. After step 2, we have step 3 of selection. The chromosomes are given percentages for how likely they are to be picked, and this is based on their fitness value. And after this step, we will be pairing chromosomes together and preparing for the next stage. We can see that because all ones here had a very low fitness score, it is very likely to be selected within the stage. And these two had average scores, so they have average percentages. This one has an abysmal percentage because it had a very poor score. And we can look after that we now have them paired up into pairs. Um, they each are going to be prepared soon as we go into the next stage of crossover. All right, now we begin step 4, known as crossover. The pairs will now swap their genes to create the next generation. And these pairs, we can see one pair of parents in front of us now. A common method used during crossover is picking a pivot point and swapping the genes based on that pivot point. So we can see here that our pivot point selected the first 2 genes of the first parent and the last 4 genes of the second parent to create this child chromosome down here. This child chromosome will now be passed into the next phases, and these 2 parents will be forgotten this time. After crossover, we begin mutation. There's a small chance for mutation to occur on each chromosome. This causes a chain of bits to be flipped, and it keeps the genetic pool diverse so that premature termination of the algorithm does not occur. So we can see with our chromosome that was given to us from our previous example is right here. There's a small chance for it to occur, and as it does occur, there's a random chance for the bits to be flipped. And this time it randomly chose positions 1 through 3. So you can see here we start at position 1 and go to 3, and those bits are flipped. And this is now the new chromosome being passed on to the next stage of the algorithm. Alright, so we have now reached the final stage of the algorithm, known as termination or convergence. Checks are run to determine if the current generation is sufficiently different than the previous generation. If they're very similar, then the solution has been produced and the algorithm will terminate. However, if there are still large differences, we will return to step 2, which is determining the fitness score, and we will do that with the current generation and iterate again through the algorithm. Alright, and that is how the genetic algorithm works. Thank you for watching my presentation.